Welcome students to the problem in semiconductors. So here is a Zener diode. They have, you can see the circuit. 9 volt is the EMF of the circuit. 200 ohm is the resistance between A and B, and there is a Zener diode and a load resistance parallel to Zener diode. Now they said Zener breakdown voltage is 5.6 volt. What is Zener current? So first of all, what we need to do whenever these type of problems are given, first of all, we have to find out what is the current through AB. What is the current through AB? As you know, VA is equal to how much? 9 volt, and VB is equal to 5.6 volt. VB equals to 5.6 volt. So VA minus VB equals to 9 minus 5.6, that is equal to 3.4 volt. So IAB equals to, or I 200 ohm equals to 3.4 by 200 amps. That is 1.7 into 10 to the minus 2, or 17 milliamps. Now, whenever it is divided between Zener diode and load resistance, what we will do? So I load, that is current through load, equals to how much? So 5.6 divided by 800, because both are in parallel. So equal potential difference. So 5.6 by 800 ampere is the load current. So 5.6 by 800, that means 0.7 into 10 to the power minus 2 amps. So that is equals to 7 milliamps. So load current is going to be 7 milliamps. So if load current is 7 milliamps and the supply current is coming 17 milliamps, so this has to be 10 milliamps, because so Iz equals to 17 minus 7 milliamps, that is equal to 10 milliamps. Thank you, students. Welcome students to another problem. Here you can see a diode, both diodes are there. 150 ohm resistance, and then in this one also 150 ohm resistance, and here is also 100 ohm, and it is a 6 volt of EMF, and there is a 50 ohm forward resistance. That means diode to be forward biased in that way, and finite backward resistance they have not mentioned. So what we need to do when these type of problems are given, first of all you need to see which diodes are forward biased, from which these diodes the current will pass. So this is positive and this is negative. So will it be forward biased? No. So no current will pass through it. This is positive and this part is positive. So this is forward biased. So the current will directly pass through it. So 150 it will pass, and then it will pass through 100. That is 250. And again 50 ohm is there. So that is 300. So that is I equals to 6 by 100 plus 150 plus 50. Here 150 no current will pass through this one, as it is a reverse biased. So it will be an open circuit, and this will be from where this one the current will pass through this tube like this way, and a 50 ohm will be there. So 6 by 100 plus 150 plus 50, so it will make 6 by 100 plus 200, that is equal to 6 by 300 amps equals to 1 by 50 amps, or 0.02 amps equals to 20 milliamps. Thank you, my students. And basically what's the function of diode? It is to convert AC to DC, and Zener diode, it is used in voltage regulator, which we did in earlier sir. Hello, welcome students. So once you can just check it out with this waveform type of circuits. It's very important for all of you. So this is input A. Input A is this one, that means above 1 is always 1, and below 1 is 0, and this is 1, and again it is 0. And B, input B, this is 0 and this is 1 and this is 0, again it is 1, again 0, and again 1. So now first question they have asked, output C will be passed through AND gate. That means this input should be passed through AND gate. So output C we will see from AND gate. So output C, what we will get? We know the truth table of AND gate. Multiple of two products, two inputs is AND gate. So 1 into 0 is 0, I believe. So it will be 0 here. 1 into 1 is how much? Is 1. So it is 1. Again 0 and 0. How much is it? 0. 1 and 1 is how much? It is equals to 1. Again 1 and 0, that means 0. And again 0 and 1, the output is 0 here. So this is an AND gate. Now output D will be, that means when A and B will be passed through OR gate, means A and B should be passed through OR gate, then what will happen? 1 plus 0 is how much? 1. Then 1 plus 1 will be 1. Very good. Here 0 and 0 will be how much? 0. Here 1 and 1 is how much coming? 1. This much 1. And next 1 is 1 and 0. That means 1 plus 0 is 1. Here 0 plus 1, that is also 1. So you can see the circuits nicely like this way. Thank you, students.